In 1976, a horrible thing happened. There was a mysterious and aggressive outbreak of pneumonia in the city of Philadelphia. Doctors were befuddled. They hadn't seen anything like it before. However, everybody that had been infected had recently attended an American Legion convention in the city. So the disease was called Legionnaires Disease. After the causal agent was identified, a pesky little bacterium, it was called Legionella. Now, for those of you that don't know, the American Legion is one of the largest veteran organizations in the United States. And that makes it very near and dear to my heart, being a veteran myself. I was a combat medic, like Robin was saying, with the Army. And during my time overseas, I got very interested in the differences between groups, specifically large and small groups, and how those differences affected people's health. Now, I said earlier that Legionella was a pesky little bacterium, and that's definitely true. But it's not the whole truth. Legionella is also very ingenious. It preys on organisms much larger than itself. It specifically likes protozoa, and of protozoa, its favorite tasty little treat are amoebas. This is a picture of a cute, innocent little green Legionella being grabbed by a big, strong, hungry orange amoeba. The amoeba wants to eat it. And you can imagine that's probably pretty scary for the Legionella. But in reality, that's exactly what Legionella wants to happen. Here's a picture of what happens once the Legionella gets inside of an amoeba. That big blob there in the center, that's an amoeba. Legionella really wants to be eaten by protozoa. In fact, if there's a protozoa swimming by near the Legionella and doesn't try to eat it, Legionella can reach out, grab onto it, and try to force its way inside. Once inside, Legionella stops the mechanisms that are designed to digest it and break it down, and instead starts reproducing. All those little black dot and rod shapes inside the amoeba there, those are new Legionella cells. And eventually, they will grow so numerous that they burst out and swim off to infect other protozoa. Another ingenious thing that Legionella has figured out how to do is that while hiding inside these protozoa, it can escape other things in the environment. Other things that may want to eat it, other things that may try to kill it, like disinfectants. And it's used this trick to get into our water systems. See, if a Legionella is hiding inside of a protozoa while it's in our water treatment facilities, it can invade the vast majority of our water disinfecting procedures. And then it slips right into our water distribution pipes. Inside those pipes, its creativity doesn't end. It will find these gooey little mats growing on the inside walls of our distribution system and wiggle its way down inside. These gooey little mats are called biofilms. And this is what I like to think of a biofilm looking like. They are communities of multiple different organisms that exude this extracellular matrix in which they can all live in protected and interact with each other. Legionella will get down inside these things and be protected from any sort of disinfectants we send through the pipes. Then it will start to reproduce again and eventually start sending little new Legionella out into the water stream, or chunks of the biofilm can break off and send it floating downstream. Unfortunately, though, biofilms don't look like this. This is what they look like. That's an actual pipe from somebody's actual home. This is what our water runs through. This is a little bit of an extreme case, but biofilms are all over our distribution systems. And once Legionella is back in the water flow, it can travel through these pipes and get to us. It can come out in our faucets, when we flush the toilets. It can come out when we take a shower. Basically, anytime we're running water out of something. And if that water becomes aerosolized, then we can breathe in little particles of infected water, and that Legionella can get down inside of our lungs. Inside of our lungs, Legionella will be introduced to our immune cells, which normally is fantastic, because our immune system is designed to push out bacteria that aren't supposed to be in our bodies. Unfortunately, though, some of our immune cells are called macrophages. And these macrophages look and behave very similar to Legionella's favorite tasty little treat, the amoebas. Legionella can infect these macrophages the same way it could an amoeba, and then Legionella's reproduction cycle starts all over again. Our lungs begin to fill up with fluid, dead immune cells, and a whole lot of bacteria. That's pneumonia. And that pneumonia is Legionnaires disease. Unfortunately, Legionnaires disease has a pretty decent mortality rate, especially if you're really young, really old, or immunocompromised. This chart here, it shows the amount and type of waterborne disease outbreaks in the US since the 1970s. And as you can see, overall, they've been going down pretty steadily, and that's great. Unfortunately, though, these little black bars here in this corner, that's Legionella. Not only is it increasing as the overall percentage of waterborne disease outbreaks, but it's also increasing in frequency pretty drastically. We're not really sure why Legionella is becoming such a problem, and it presents differently between urban and rural environments. There's a metric called water age, which may be affecting this. Water age is basically the amount of time that the water has been in the pipes before it gets to you. Now, increases in water age are associated with decreases in the effectiveness of disinfectants, other things like increases in the amount of dissolved organic carbon, and because both those things are great for microorganisms, it's also associated with the increased number of microorganisms. And generally speaking, because of the way pipes are laid out and the number of people flushing water through the system, you usually have older water ages in rural environments as opposed to urban environments. Another problem with rural environments is resources. They generally don't have as many as the big cities. And because of that, they have a little bit more difficulty keeping up with health-based regulatory violations. These health-based regulatory violations usually pertain more to concentrations of coliform bacteria, other bacteria, and some contaminants. All these things add together to make rural water distribution systems a much more inhabitable place for organisms like Legionella. Unfortunately, though, that's not what we see, and this defies all of our expectations. Legionella is becoming an urban disease. We see much higher concentrations of it in urban water and extraordinarily higher rates of infection in urban environments. And we haven't figured out why this is yet. One idea that we're working on is that Legionella might be so dangerous to humans because it's a social organism. It has multiple different types of relationships with the organisms that exist in the water systems with it. This guy right here, this is Pseudomonas, or bacteria related to the Pseudomonas family. In urban environments, this is Legionella's best friend. They're always found in high correlation with each other, and certain strands of Pseudomonas have also been shown to encourage Legionella to multiply. When Pseudomonas is present, there are certain other bacteria that aren't. Like this guy here. In rural environments, where infection rates are much lower, this is one of Legionella's best friends. This is E. coli. E. coli is a coliform bacteria, which is a subcategory of the Enterobacteria family. In rural environments, Enterobacteria is much more highly associated with the presence of Legionella than any other bacteria is. We aren't really sure what's going on with these relationships yet, but we are starting to find that depending on what friends Legionella has around it, it can have a much different outcome when it comes to how it affects human health. This is an entirely new world that we're creating for Legionella and these other organisms. These new man-made water systems are this entirely new ecosystem that these organisms are still figuring out how to live in and what special little niches they're all going to fill. The research that we are conducting currently is looking at these social relationships and how we may be able to manipulate them in order to help impact human health. So far, we have seen that Legionella, who have already infected a protozoa, are much more capable of infecting human cells. In systems where infection rates are much higher, Legionella is much more highly associated with bacteria from the family Pseudomonas. In fact, certain strands of Pseudomonas can encourage Legionella to multiply. And in systems where Legionella has a much lower rate of infection, it is much more highly associated with bacteria from the family Enterobacteria. This is particularly important right now, because not only are we creating a new world for these organisms, but humanity itself has recently entered into a new world. In roughly March of 2007, the United Nations reported that at that point in time, humanity had crossed a new line. For the first time in human evolutionary history, more than half of our species was now living in dense urban populations. It's something we'd never experienced before. And they project by 2050, more than 2/3 of us will be living in these new city environments. We're all moving into places where rates of infection from this guy and other organisms are much higher. We are changing the environment of our health. And as we create these new environments for us to live in, we're also creating new environments for the organisms around us to live in. We need to understand how these processes are affecting them, and in turn, how they will be affecting us. Thank you very much.